So the work we've done can help identify two results. Now you don't need to know how to create these results, you just need to remember these for Core 1. So the first one is the remainder theorem, and it says if we have a polynomial p of x, so this could be any quadratic, any polynomial. We've only looked at cubic functions today, but it could be anything. If it's divided by x minus a, then we will be left with a remainder of p of a. An extension of this is the factor theorem. So now let's imagine we calculate p in a and it equals 0. Well, that means that the remainder is nothing. There is no remainder. And if there's no remainder, it means that x minus a is a factor of that polynomial. Now I'm going to give you an example of this in use, and then we'll do some questions to apply. And these will be the exam style questions. I'm going to start with my polynomial x cubed plus 4x squared plus x minus 6. I'm asked to show that x plus 3 is a factor, and then I'm going to try and fully factorise my polynomial. So using my factor theorem, if x plus 3 is a factor, then p of minus 3 would have to equal 0. So let's try that. P of minus 3 is going to equal minus 3 all cubed plus 4 lots of minus 3 squared plus minus 3 minus 6. Well, minus 3 times minus 3 is positive 9, times minus 3 is minus 27. And I'm going to add, minus 3 squared is 9, 4 lots of 9 is 36. Then I'm taking away 3, taking away 6, and that gives me an answer of 0. Fantastic. So I've shown that x plus 3 is definitely a factor of p of x. Now I'm asked to factorise it. Well, to factorise it, I'm going to use the skills we've used earlier on. So first of all, I'm going to start with my cubic expression. And this is going to be factorised, so I'm going to take x plus 3 out and work out what comes next. So x times, it's going to have to be x squared to give me x cubed. But now I've created 3x squareds. I need another x squared to get up to 4x squared, so I'm going to add an x so that when these two multiply together I get 1x squared. But now I've created 3 x's. I need to get down to 1x, so I need to lose 2 x's. So I'm going to have a minus 2 here. So when it's multiplied with this x, that gives me minus 2x. And now I've created a term minus 6, and I'm done. I've factorised my cubic expression into this linear expression and this quadratic expression, and there's no remainder. So to fully factorise, all it remains to do is to factorise this expression here. So I've got x plus 3 and by whatever means you use for this factorisation, we should end up with this result. So if I'd been plotting the curve p of x, as we were talking about previously, I can see now that I would be intercepting the x-axis at minus 3, minus 2 and positive 1. But here is my full factorisation. Now, turn to page 93 in your textbook, and can you complete questions 2, 3, 4 and 5, please?